Okay, so hello everyone, I'm Alfian and today we are going to solve the Hackerrank challenge on the React section called the word Omitter. And for this particular challenge, we are tasked to create a simple React application that dynamically filters out specific words from the user input in real time. So every change here will be reflected to the output form below this. The detailed requirements for the number one, the word omitter component takes an array of words to omit as a prop called omit words. Each element of this array is a string representing a word that should be filtered out of the user input. And for the number two, the application should display a text input field where the user can type a sentence. So this is the input field that we mentioned earlier, and we can look over the word omitter.js, which is the one that we are going to work here. It's already providing us with the useState, a bunch of useStates such as input text and omit words state. And for this constant right here is the array of words or array of strings called the omitted words in a form of the variable is all in a caps lock or upper cases. And for the number three, as the user types the output area below the input field should display the sentence with the specified words omitted. So as we type river right here, and the output will display river. So let's just do it. It's already provided by the handle input change, and for the set input text, it's handling the target.value. And for the state right here, input text, let's see if the render is displaying correctly. So it's already providing us, and to make our work much more easier in this particular challenge. Yeah, that's very nice of the one that makes this challenge. And let's reflect the output right here after as we type the input. Let's say we type reference, and then get processed text, and we can add another check if we either displaying the filtered one or the unfiltered one. To do add check for filtered and unfiltered one. And for this demonstration, I will just display the output that has been reflected from the input field just by passing the input text state. So let's type reference, and then the output is also displayed here, and it should be in a form of unfiltered one because we will add a check for the filtered one. And then for the number 4, the application should have a toggle button to switch between the omitting the specified words and showing all words. So let's do this by using an if clause. If the omit words, which is a boolean state right here, and the toggle omit words is already declared ahead, set omit words, using the exclamation mark to toggle between the true and false. We can use this one, or we can use another one like set omit words, that text the previous, and then using the previous as the parameter with the exclamation mark in front of them to make it toggle between true and false. If it's true, then negating using the exclamation mark will return to false. If it's already false, the previous value, then it will return true because it's rendering the previous value is already false. And so let's make the if omit words is true, then return filtered, just like this. So let's type reference and show all words. Let's omit the words again, and then it will return filter, and the input text of the unfiltered one will be will not be rendered. And you might be wondering why the get process text is being rendered correctly as we type instead of using useEffect. Is because the get process text function right here is already declared right here on the renderer section inside the p tag, and the get process text as the function it will be immediately invoked as we make a change in our useState variables, and it will be reflected immediately. So it's just another way instead of using the useEffect. So let's change this back to use the original author code right here, code by the author. So let's show all words. Let's omit again and show all words again. It will display reference the original input text, and the omit words again, it displays the filter one. And we will change this string to be the actual filter text. And then for the number 5, the application should have a clear button that clears both the input field and the output area. Should have a clear button. For the clear fields, we can declare that input text, since it's just clearing the input text, and any changes will be reflected to the output, and the output will also reverse to the input field right here. If we set input text back to the empty string, then it will be reflected as the input text right here on the value right here, input text, and then everything will be chained together. Let's clear this, and it's not being reflected on the output right here. So all words. Okay, so let's type something right here. It's because we are hard coding the filter on the omit words right here. Don't worry about this. So let's clear this. It should be reflected automatically in the output section. Okay, so for the number 5, it's already completed. Let's go to number 6. If the input field is empty, the output area should also be empty, and we already did that. And so for the sample interaction, the input field is empty, the output area is also empty. So let's reload this. This is for the initial state of the area component, and then it should be filtered. Let's make this empty string, and we already know the omit words clause, the if check right here is already returning correctly, so we don't have to worry about returning something other than the filtered words or confused between the filtered one or the unfiltered one. The output area is also empty, the input is also empty, and the button display show all words omit mode is enabled. Okay, so let's reload this. Check if the show all words is enabled as the initial state. Yep, it's already true. I wasn't editing any of this, it's from the author. So for the user action 1, user types this is a test sentence, and then since it's a filter, then it will return the empty string. So let's make this work at our change by declaring by splitting the word. So let's say if we have this test sentence, if we have to check one by one to check if there is a string, or there is the string and string or all string, checking if one of the string or inside the input field right here is containing one or more of the omitted words that we should omit from the input field right here as the output. So let's declare a constant value of the split words, and we can take the input text using the split that takes the string. Okay, so for the filtered one, let's use the split words. I hope it's working. And the split words is not displaying any space. Okay, let's, since it's not rendering a space. We need something to make the space also not just as a delimiter. So let's say if we declare this is a test sentence, then not just make this an array of this and then comma. Let's visualize this comma is comma a comma test comma sentence. Since the delimiter is a space, then it will be converted as like as a separator of the array like this. We need something to make the space also being considered in an array. For example, this and then comma, and then the second element will be the space itself, and then after the space is and then the empty or the space again, because after is a space. We need some kind of that, and to achieve that we can use the Array.split. I already declare something here using the regular expression, so include the delimiter as the character inside the split. So let's run this. Let's remove something unrelated from this challenge. Okay, so for this one, for the first console log, I am using the regular expression that takes the empty space using the plus sign. Plus sign is the one quantifier, which is equals to 2 or more, I think, or 1 or more empty space, and also covered in parentheses, so the space is also included inside the array. So it's like this one, the and then comma, and then the empty with the space, and then comma again, and then quick comma, and then the empty space again comma, instead of just the comma quick comma brown comma like that. And as you can see, there is a difference between using the regular expression or just by passing the empty space inside empty space as a string inside the split argument or parameter right here. The difference is really important. Okay, so let's go back to our implementation by using the, let's make this wider. Implement this passing the regular expression and takes the parentheses, and then using the escape string with the plus sign after the splitting. Then we need some kind of filtration system. We can declare a constant filtered words, and then takes the split words from the array right here, and then using the filter function, and then for the filter we can take the word, just a single word, not the plural one, and then since we are going to process it in a complex manner, then we can pass in the curly brackets to see if the word right here of the split words of the this is a sentence is included in the omitted words constant right here. So for the filtered words of the filter, if the this is included in the omitted words, then the word of the iteration right here, if the word is returning of the current iteration, if the current iteration of the first iteration, let me replace this. So let's say if we have the this is a test sentence, then the this is the first element, and the word, the current iteration is this word right here. If this is included in the omitted word array, then we need some kind of mechanism that will return false, and then the filter right here, if the current word is false, then it's only returning is a test sentence. So it's just by returning either true or false of the current word right here. Okay, so let's declare this by declaring another constant inside the filter, and we need to clean a word. The the purpose of clean word is just to clean the said word from the punctuation. Let's say if we have a symbol or like a dot or a comma or a question mark or exclamation mark beside the word, then we can clean it first before we process it. So by using the declaring the clean word that takes the word parameter from the filter, and then we can use the replace function to replace the one that is not. We can use the regular expression, we can filter out, or we can exclude the symbols from the actual word right here. So by declaring the square brackets, we need to remove anything other than the word by using this caret to negate or exclude anything that is not word or alphabetical. Let's say A to Z, either uppercase or A to Z as lowercase. That way we are removing this to just an empty string without the space, and then we can return using the omit words array. Omitted words, let's see if we use this correctly. Okay, omitted words, and then includes, check if it includes the clean word that we already clean right here without the punctuation or without the symbol marks. If it is, then we should return false right here to the filter right here. If it's false, then it will not be included in the filtered words. So since the return this one is equals to true, if this is included in the omitted words, the return will be returned true, and then the filter word is not going to filter the this because this is included. So we need some mechanic to flip or to negate the result by simply use the exclamation mark in front of the expression right here. So we will return a word that is, since it's includes, then we will return the word that doesn't include the clean word right here. In other words, we clean this first of the current iteration from the punctuation, and then check if the current word does not included in the omitted words. Hence we use the exclamation mark in front of this. So what about capital words or typing all upper cases or all lower cases? And for the omitted words is only lower cases. So to achieve that, we can just use normalization to compare the clean word one with the omitted words, to normalize the omitted words array with the clean word that we are going to use to check if it doesn't include. So in order to make this case insensitive, to achieve that, we can change this to lowercase. So let's say if this has the uppercase right here for the T, and then make this a lowercase, and then it will return this with the lowercase this. And then for the omitted words, we also change anything in the omitted words as the lower cases and normalize between the two. How to achieve that is by using, since it's an array, we can use the map to make a shallow copy of the omitted words array, and then we can add list as the parameter or word or anything. Just don't get confused of the word parameter that we declare inside the filter, because the map is still inside the filter function right here. So we can use this and then chain it with the toLowerCase, and then that way we will return the shallow copy of the omitted words. So let's say if the omitted words has all uppercases like A, D, N, or N, but, and for the omitted words right here, the map list to lowercase, it will return a shallow copy, but all in lower cases. So it will be compared against this clean word with also with the lowercase. So we don't have to worry about the case sensitivity anymore. So after all of that completed, don't forget to process the filtered words, process it back, and rebuild everything back to normal, because we are going to return the if the omit words is checked, and then change this placeholder from the empty string to the actual words that we already rebuilt from the split words array right here. And the filter one, just by passing the SD constant, rebuild words, or rebuild sentence, and then for the filtered words, we can pass in the filtered words, and then using the join with just the empty string right here without the space. You might be wondering why I am using the just empty string instead of space right here. It's because the filtered words right here, or if you remember correctly from the split words, it has the this and then space from the delimiter that also include in the array, and then is, and also added again the space as the element of the array. So that's why we don't have to worry about using another space and then just joining it, and then joining will result in a string form as a whole. Let's say if we have the this is a test sentence, the this, and then will be added, we'll add like this, and then space, because we already declared a space, empty space as the second element, and then is, and then space again using this one, so and so on and so forth. And then after join this, don't forget to replace using the, you might be wondering why I'm also using the replace, chaining it with the replace. We don't have to add another replace right here to make this implementation complicated. So for this case, let's say if we declare this is a sentence, what if we have a sentence as the omitted words, or adding another a in front of it, a sentence as the array, and then using the clean word against the omitted words array right here. This is the omitted words array, and then let's say this is the split words, and it's already been cleaned from the out of the punctuation. And then the result, if we don't use the replace right here, that I will implement it later, if we don't use this, then the array, of course the filtered words is in a form like this, and then comma, and then empty space, the second element, and is, and empty space, since a is already excluded from the filtered one, and then a will return like this. Not that a is already excluded from the filter, and then it's not transform, the transform one is not the a, but another white space, because after is a space, and then a is excluded from the filter one, and it just returns the empty string right here without the space. And after the a is also another empty space, and then the sentence is already excluded from the filter one. So the resulting string will be the, let me use the tile mark, or the, how do I pronounce it, tile, I don't know, this, and then space, is, space, and then space again. And we don't want that, double spaces. And let's use a regular expression again to make a double space, to just a single space. And then since replace can take two parameters, for the first parameter we can pass in a regular expression with the G or the global tag, and then global tag is checking on any part of the string that we need to check, and then we can pass in the escape or the backslash with the S that representing the space. And then for the next one is the plus, is just the replace it. The regular expression filter right here is to check if the empty space right here has two or more spaces. If it is, then it will be replaced by just one space like this. And then let's use the empty string right here, or just single white space, and the resulting string will still return like this. This is with the single space, and then there is no other word. So to make the this is like this to be just this is with no trailing empty space, then we can chain it again with the trim. The trim is a function to return the string and removing the empty spaces from the text and after the text or after the string. Yeah, removes the leading and trailing white space and the line terminator, which is the enter or line break, or I don't know. For the trim right here, it's already completed for the rebuild sentence. So let's return the rebuild sentence, and let's use this. Okay, so let's reload this, and let's test this out. In this is test sentence, and it's returned this is test sentence. So let's show all words. This is a test sentence, this is a test sentence. Okay, let's clear this one. Okay, so let's test this. Okay, so let's get up from the full screen mode. Let's remove this one. Let's run the test again, and let's submit the code. Okay, so that's about it. I hope you understand this video. If you still don't understand, you can ask me in the comment section, or if you have any better solutions, you can also tell us in the comment section. I hope you have a great day, and I will see you in the next video. Goodbye.